Good afternoon, everybody. And I want to welcome you all to showcase of our virtual simulator laboratory. My name is Miloš Popović, and I'm director of KITE. And KITE is a research institute at the UHN, University Health Network. Today, we'll be taking you 3 floors below the busy intersection of the University Avenue and Elm Street in downtown Toronto to explore revolutionary space that many people like to call Rehab NASA. We are excited to demonstrate how our impressive lineup of labs are used to conduct practical research experiments, and develop and test variety of products in several challenging conditions that replicate situations that we all are very familiar with. Our labs can recreate icy surfaces, challenging driving conditions, noisy street, steep stairwells, and slippery bathtubs. This allows us to test the safety and performance of winter clothing, footwear, assistive devices, hearing aids, emerging technologies, and pharmaceuticals that people use almost every day. We've been featured in Nature of Things with David Suzuki, the Merceners Report, that one you should see, it's hilarious, CBC Marketplace, and CityLine. So today I will just introduce you to the institution, and then my competent partners and colleagues are going to walk you through different laboratories. So Jenny Campos will walk you through Street Lab and Driver Lab showcase. Sophia Lee will talk about Winter Lab and Stair Lab showcase, and then questions and answers will all contribute to that, and we also have Bruce Haycock and Andrew Turner, who will be delighted to answer any questions that you may have. Okay, so can we go to the next slide, please? So very briefly about the institution, about KITE. KITE is actually an acronym. It stands for Knowledge, Innovation, Talent, and Everywhere. Next slide, please. And KITE is a research institute, as I mentioned earlier, and it's dedicated to improving the lives of people living with effects of disability, illness, and aging. Next slide, please. And our focus include research focus include injury prevention, restoration of function, enhanced participation, and independent living. Please, next slide.
I'm ahead of the game. Up my rocker, but follow me, I'm ahead of the game. I'm ahead of the game. I'm only ever slinging, I'm working overtime. Got a song and I'm the singer, the melody, the vibe. I'm a prodigy, logically, I'm impossibly wanted. Then they'll remember my name. They'll remember my name. Said you know I always bring it, I'm finer than the wine. And the clock is always ticking, getting until the time. But because you can walk with me, I'm a rock, you can roll with me, I'm ahead of the game.
So this video was essentially a snapshot of what we do in about a minute. I'm sorry I didn't introduce the video properly, but you can see what kind of things we do, from robotics to falls and various treatment therapies for swallowing and other things. And if you're interested, you can go to our webpage and you can see that video again, or you can explore it and find out what else we do. What is relevant for you to know is we are part of our hospital is actually a hospital system consisting of 7 different hospitals in Toronto. And we together represent this institution, which is called Trent Rehabilitation Institute. And on this image, it's a building where you have a wheelchair on the right side. So our hospital system is partner of another 4 hospitals, which is Princess Margaret, Toronto General, and Toronto Western. And these hospitals have jointly a large research institute, which is UHN's Research Institute, which is considered #1 in Canada in size and productivity in the medical space. And we have, as a hospital, we have 11 different medical programs. We have 7 individual research institutes. Kite is one of those 7 research institutes. We have 1 educational institute, and we have 2 foundations. Next slide, please. So this is a snapshot of what UHN is doing in research space. So we have about 1,100 plus principal investigators. Our annual revenue in peer review funding and such is about $490 million. We have about 3,500 trainees and staff, 1 million square feet of space, and whatchamacallit, and we have about 3,600 publications which are produced annually by this huge enterprise. So you're looking at really an outstanding and tremendous enterprise in research, in medical research. Next slide, please. So what is relevant for you to know is University Health Network with its research institute is a part of even a bigger system. And this bigger system is actually various hospitals which are affiliated with University of Toronto. And besides University Health Network, the hospitals which are part of this system are also a Hospital for Sick Children, Center for Addiction and Mental Health, Baycrest, Mount Sinai Hospital, St. Michael's Hospital, Women's College, Sunnybrook Health Science Center, and Holland Bloorview Kids Rehabilitation Hospital. And all this is a part of the University of Toronto educational system. So on my part, in closing, I hope you're going to enjoy this presentation today, and I'm leaving you in the competent hands of Drs. Campos and Lee, who is going to present the laboratories for you. Thank you.
Thank you, Milos, and welcome everybody. I'm Dr. Jennifer Campos. I am a senior scientist at Kite, and I'm also an associate professor of psychology at the University of Toronto. So I have the pleasure today of telling you about a couple of our state-of-the-art simulation labs. We have many labs and research facilities across Kite, but today, as you know, we're focusing mainly on a collection of simulators that exist at our 550 University Avenue University Center location in downtown Toronto. The advantages of simulation, I think, are apparent to a lot of you, but what we are using them for is really to allow us to study human abilities and performance and to come up with products and technologies to improve the well-being of people from a variety of different perspectives. And simulators give us the ability to control a lot of our variables of interest in a very safe way, but they also allow us, most importantly, to be able to translate our research from the perspective of being able to carefully reproduce, realistically mimic the challenges that people are experiencing every day, and thereby moving the results of the research from lab to life. Next slide, please. So this is just an overview slide. We're going to go into details of each of these labs in a moment, but these collection of simulation labs that exist in one location have historically been called together collectively the Challenging Environment Assessment Lab, and it's comprised of 4 separate labs. In the top right-hand corner, you can see Street Lab. In the bottom right-hand corner, you can see Stair Lab. The bottom left-hand corner is Winter Lab, and the top left-hand corner is Driver Lab. We're going to give you the details of the properties and the usages of these different labs in a moment, but what you can see in the center is a large motion platform. And what is one of the unique things that is specific to these labs is that all 4 labs that you see in all of those quadrants are actually portable labs. And so what it allows us to do is it allows us to move these labs onto this motion platform for circumstances and for research projects and applications where we require motion. So this motion platform allows us to move these labs around in 6 degrees of freedom. So that means that we can rotate it and yaw, pitch, and roll, and we can move them linearly in XYZ dimensions and all combinations thereof. I think for a lot of people, the sort of intuitive and common use of these types of motion platforms are in the automobile industry and the aerospace industry, where it becomes important to move vehicles and platforms around systematically. But we use it for other reasons as well, including tilting the ground surface, which you'll hear about, so that we can look at mobility issues related to the built environment. So how can we navigate slopes and cross slopes? And sometimes we want to create perturbation. So we want to be able to disturb people, for instance, when they're attempting to balance, to look at balance recovery mechanisms and things like this. So you will see in the next slide a time-lapse video of how these labs can be moved around in space. Here it comes now. So there's a large crane that can lift up each payload. There's a large space where they can be parked, but it's not that they're parked there and they remain inactive. In fact, they are all completely equipped to operate independently while they're parked. If you don't need motion for your studies, then they can all be used simultaneously at the same time without motion, but of course one can go on the motion base. And so you've just seen here that it takes a couple of hours in terms of connecting and reconnecting, but the moving of payloads in labs is really quite straightforward, and it's something that we do on a regular basis as need requires. But again, these are all independent labs that can be used for their unique properties and purposes. So if you move to the next slide. We'll start off by talking about street labs. So for each of the labs, I'll tell you about some of the technical features, and then we'll talk about some of the potential uses of these labs. So Street Lab is our virtual reality simulator. It's a 240-degree field of view projection-based system, a cave-based system, curved cave-based system. And it also has a floor-based projection, so that essentially the entire field of view is taken up with the immersive environment. It also has a series of speakers that are behind a sound permeable screen, so that we can create spatialized sound, surround sound, and a subwoofer that exists at the bottom. It has different ways that we can interact with these virtual environments that are projected. So we have a linear treadmill that can be inserted into Street Lab so that you can move naturally through the virtual environments by walking. We also can navigate through the use of more artificial devices like joysticks. And we have a force plate that can go in here as well, so that we can measure standing balance as people are experiencing this virtual environment that would replace the treadmill at the center of the lab. Like many of the other labs that you'll hear about, we have a lot of different ways that we can measure behavior and physiological responses in these labs. So for example, in Street Lab, we have motion capture systems that can be put in, so we can look at full body kinematics as people are walking or are moving within the space. We have abilities to use mobile EEG systems and eye tracking systems. And then we have physiological response measures that we can also track, including heart rate and galvanic skin response and things like that. So these are all things that are sort of technically possible within this, this immersive virtual reality space. The software we've been using mostly lately is Unity. We also have a big Toronto database. So we have several city blocks of Toronto that have already been programmed in here using as a rendered graphics program. But essentially, whatever it is that you need is the really wonderful thing, of course, about virtual reality is that you can create any kind of environment that is required for the various applications that you would need. Next slide. So here is just, a very sort of high level list of things that we have either used Street Lab for in the past, or that it has commonly used for. So the first item is screening and as a screening and training tool for or tool development for the detection of early cognitive decline. So the nice thing about these types of virtual reality spaces is that we can create something we refer to as a brain stress test. So this doesn't mean that we're trying to create anxiety in people, but what it means, like a cardiac stress test where you're looking to see what the upper capacity of someone's heart is that we're looking at the upper capacity of someone's brain, which means in your everyday lives, when you have to walk and listen and talk and look and think and plan all at the same time, sometimes these measures are more sensitive to these really sort of simplified paper and pencil tasks that you often do in a quiet and in controlled environment. So we've used it for that purpose before. Design of the built environment. So in the context of navigation, looking at development of signage or communication strategies to help people with wayfinding and moving their way around novel spaces. We've done some work in the context of pedestrian signaling. How do you develop signalings at crosswalks that are optimized not just for people who have visual impairments, but also for people who have low vision and hearing impairments, for example. Balance and gait training. So again, creating the challenges that would be common that people would be experiencing in everyday life and try to use those to train people. Development of exposure-based therapies is a common application of VR. So for instance, for individuals who have specific phobias, to introduce the stimuli that creates the anxiety and sort of use a graded system of exposure. To extinguish that. Gaming and VR development and optimization is obviously a big one. Lots of different applications here, ranging from entertainment and health related applications. Something that we're working on specifically as it pertains to optimization relates to mitigating adverse side effects. So as many of you are probably familiar with, simulator sickness can be a problem in simulated environments. So what strategies can we use to mitigate simulator sickness for these applications? Hearing aid development and optimization. So historically, hearing aids are often tested and modified based on a sound booth being in a very quiet, optimal sound booth environment, which is obviously an ideal listening situation, not really representative of what people are challenged with in their everyday lives, where they have to listen in noise while at the same time thinking and moving. And because we now are starting to get some indicators that things like falls risk, individuals with hearing loss, age-related hearing loss, have 3 times greater risk of falling. We want to know why that is, and so that we can optimize hearing aids to help mitigate that. And one of the possibilities is that when you have to listen and do other things at the same time, hearing loss increases your cognitive load, which leaves less resources for doing things like supporting balance. And then there's lots of applications in the context of professional and training and education that we can optimize because we can create all of these different challenges and interfaces that would be specific to those applications. Next slide, please. So the next lab is Driver Lab. So Driver Lab is the most advanced driving simulator in Canada. It is a full car, as you can see, and it has all of its internal components retained. It is on a motion base. So you can see its own little rotating motion base within the dome. So you can see at the bottom right in the center underneath the car, that's a rotating platform. We think this is a very important feature because instead of swinging the visuals around the user, we are moving the user, the person within in reference to the visuals, which we think is also really important in terms of mitigating simulator sickness again, and creating fidelity. This vehicle has a couple of unique features that we don't know of any other driving simulator that also has them. One is a glare simulator. So there's a robot, a sort of robot actuated arm that is located underneath the vehicle. And that can be actuated and it has a strip of bright LED lights on it. That strip gets superimposed, for instance, on the headlights of an oncoming vehicle. And those lights can therefore create the experience of a disabling glare that's really not possible through a typical projection-based system. We also have a rain simulator. So there is nozzles that are oriented above the windshield, and those can create water droplets of different intensities that require the driver to actually activate their windshield wipers and manage the task of having to have reduced visibility due to rain and clearing their windshield. It's also has embedded eye tracker. So in addition to some of those other measurement devices I mentioned earlier, we can also do gaze tracking within the simulator. And it is a 360-degree field of view projection system, as you can see. So the projection system wraps entirely around the vehicle. Next slide. Okay, so there's lots, obviously, that Driver Lab can be used for developing methods of driver assessment and training, optimization of vehicle design. We are looking at right now automated vehicles and how to design automated vehicles for a range of user populations, including older adults and individuals with sensory and cognitive decline, for instance. We are also actively assessing the effects of drugs on driving performance, including cannabis and opioids, and also having the expertise in-house of physiatrists and others who are prescribing some of these medications like opioids to have a good understanding of what's worse, the side effects of the opioids on driving or the side effects of the untreated pain on driving. We are also interested in informing customized licensing programs. So as many of you can appreciate, complete revoking of someone's license can be catastrophic. But if we can gradually reduce and introduce driving restrictions, for instance, driving during the day but not at night, driving locally but not in unfamiliar places, driving on roads with lower speed limits but not the highway, if we can customize licensing, maybe it will allow people to drive for as long as is safely possible. To look at the effects of cognitive and physical training programs on driving performance. So another strategy for introducing intervention for at-risk drivers to see how we can better their performance in the vehicle. I mentioned the optimization of automated vehicle technologies as well, which would relate also to looking at models of prediction. So using some evidence from driving performance to understand how they can be implemented within automated vehicles, but also understanding at various levels of automation, including partial automation and full automation, how accepting are different driver populations of these technologies and how are they able to perform some of the tasks that are needed in partially automated vehicles, for instance, performing takeovers if they have a mild cognitive impairment, for example. And then, of course, very interested, again, in motion sickness, looking at drowsy and distracted driving, and looking at assessments and interventions that will mitigate drowsiness, mitigate distraction in a variety of different contexts. So I think that's all I wanted to share. I will pass it on to Sophia to tell you next about Winter Lab and Climate Lab. Thank you.
Hi, good afternoon, everyone. My name is Sophia Lee. I'm the manager of partnerships as well as a staff scientist at KITE. We know that today we have many people attend this webinar, and we have many people from different industries. We notice that we have people from automobile, the car industry, the footwear industry, the construction, the safety research. So I think today we only have a very limited time, 1 hour, to give you just a peek of what we have at our institute. And we definitely welcome you to ask questions. There's Q&A window, and you can just type in your questions. We're going to monitor those questions. And also, today we didn't show you a lot of videos really to demonstrate the different aspects, especially the details of each lab. And I think the purpose of today's webinar actually is to let you know that we have all those capacities. And if you have certain questions or you want to learn more about each particular lab, please contact me. I have my email at the end, and also you get all those emails reminding you to attend this webinar. My email is also in there as well. So I'm going to give you a really quick overview of our Winter Lab and Stair Lab that is part of CEAL. that Jenny already mentioned, and also give you some examples how we use those labs. However, please bear in mind that we are open to explore the different opportunities to use those labs, because one of the things we want to share with people from different industries is we have those capacities. We'll be able to answer research questions. We'll be able to test products. So if you are interested to use those labs, please let us know. I'm going to point out several features that you can see at the screen at the moment is the inside view of the winter lab, and Jenny already showed you the outside. The winter lab is actually can be put on we call single X platform that be able to tilt the whole winter lab, so we can create icy slopes. And you can see that the floor here is pink because that's the glycol liquid that is in the tube that is buried in the floor, and then we flood this whole lab to create this almost 5 meter by 5 meter ice surface. And the winter lab itself is about 3.8 meter high. And we'd be able to attach the harness, as well as you can see that on the screen, we have motion capture system, be able to monitor and study in very great detail of how people walk, if they slip, if they lose balance, how we going to study those. And also we have the system to separately control the temperature of the winter lab's ice surface, as well as the air temperature. So the temperature in winter lab can be from -10 to +35. However, what if you think, oh, I want to simulate even colder winter? Then we actually have another lab we call the climate lab. It's a static lab, so it's not like winter lab we can put on a motion base. But the climate lab actually has a great capacity in creating temperature as low as -20. And if we push, we actually can go -25. And we can also simulate extreme heat. For example, we can go as high as +35 or even +40 with really, really high humidity in order to simulate cold and hot environment. In climate lab, we can also monitor how people walk, and we can also put a treadmill in winter lab as well as in climate lab. And in this picture, I would like to point out, you can see on the screen on the right side, there's a window over there. And actually on the other side of the window is a monitor room. So we can do a lot of physiological testing, and we have physicians or we have researchers on the other side of the window be able to monitor how people conducting the testing inside this climate lab, either in hot or in cold and with different type of conditions. So you probably will be thinking, how can we use winter lab and the climate lab? I'm just going to give you some of the examples. Of course, there's many other ways you might be able to use, especially if you want to have a cold or hot environment. And in our case, we actually have a really great service. We actually be able to test winter footwear to offer this service to the footwear manufacturers. Because even alone in Ontario, every winter, we have about 20,000 people slip and fall on snow and ice and have to go to emergency room. So what we use winter lab is we'll be able to tilt the winter lab and to create this ice surface. And then we'll be able to look at how steep, like the winter lab be able, the winter footwear be able to walk on without a slip, and using that as indicator of the slip resistance of the footwear. And of course, because we can have different exercises and activity, we can conduct those study in either winter lab or climate lab, and we can look at the physiological response. Of course, we'd be able to measure the blood pressure, the heart rate, and the breathing, and also their mobility as well. That enable us actually to look at for different patient population, and also maybe some of the clothing, how warm they are. Also for sports gears, we can look at them in cold and in hot, how those clothing and gears be able to perform. And of course, the wheelchair, the mobility scooter, the walker, the crutches, and also some of other mobility devices, we'll be able to using our winter lab to test their safety. And we also have a snow maker beside our winter lab. We'll be able to make snow. So even in the hot summer, if you want to do some test in a winter condition, we'll be able to do that. And I know that some of the audience today, you are from the transportation service or from other urban design, and we be able to actually use the winter lab to simulate different sidewalk, pavement, and we can put different pavement material in our winter lab. We can put snow on it, we can put ice on it, and we can see how they perform in the winter. So that's just some of the examples how we use winter lab and climate lab. Of course, we welcome you to ask questions and to explore, and we can also book one-on-one meeting to let you know how each lab can be used. And of course, after COVID, we hope that we can welcome you to visit our facility and to really invite you to the real tour itself, like a virtual tour that currently you can do on our website. And the next lab I'm going to show you is the Stair Lab. Of course, this lab is also the one that can be put on the motion base. And on this picture, I would like to point out that this lab currently in the picture, you can see there's a bathtub because the slip and fall and the injury due to people using bathroom is also very, very high. In Canada, every year, we have over 110,000 people actually visit ER because they have a slip and fall in the bathroom. So in this picture, you see that we're testing how we set up the bathroom. And also in this case, you probably can notice there's a grab bar besides our researcher who is in the black shirt here, and right beside her, there's a grab bar. So this setup is actually to look at how we put the grab bar on which wall, and also the shape of the grab bar, how high we should do it, and the size of the grab bar, what is the best design actually be able to prevent people fall in the bathtub. So because the Stair Lab be able to put on the motion base, we have very efficient way to make people lose balance, because if we don't have the perturbation capacity, we can ask people to go in and out of the bathtub probably 1,000 times. Then we maybe capture one incident that they're going to lose balance and grab on the grab bar. But because we have the perturbation, we put on the motion base, we can perturbate people every time they in and out of bathtub. So every time they lose balance, they will be able to grab on this grab bar and give us many, many data points. We'll be able to quickly draw the conclusion. We can test different configurations and then to look at which configuration is the best one. But don't worry, we also have this really advanced harness system. So you can see on the screen, on the ceiling, there is a harness system, and you can see the participant here has attached this harness system. So even they lose balance, they will use the grab bar, and also the harness system will catch them, so they won't really fall. And also here you will notice that we have a motion capture system, and on the floor is covered by this wood board. There's a force plate. So we'll be able to study the force and the movement of how people conduct different activities in Stair Lab. And of course, you're probably going to say, what if I want a bigger space than a Stair Lab? And also, what if I want a higher ceiling? Then we actually have another lab we call False Lab, which is a bigger space, because False Lab, we can have 7 meter by 3 meter floor surface, also with all the force plate. And we also have 5 meter ceiling height for the False Lab. So if you are interested in looking at in a moving environment, but for example, people climbing ladders or some other activities, we'll be able to do False Lab. False Lab also have the capacity to move in the horizontally, we call XY directions. So we can perturbate people in the horizontal place. But in Stair Lab, we actually be able to perturbate people any way you want. We call 6 degrees of freedom. And for examples of how we use the Stair Lab and the False Lab, for example, I showed on the image that we'll be able to set up as a bathroom. But you can also imagine if, for example, if in the audience, we have people worry about how safe in a bus. For example, if the company is manufacturing the bus and you are interested to say, how about the grab bars, the handrails in the bus, how they should be placed, then we'll be able to simulate this moving environment using our either Stair Lab or False Lab. So that is one way of we'll be able to use to say how we best design the building environment or a moving environment. And of course, the examples of grab bars. And the reason we call our lab Stair Lab is because we actually have 8 steps of stairs we'll be able to put into the Stair Lab. And then we'll be able to look at the staircase design and the hand railing design. But probably more accurately, we should call our Stair Lab like a general purpose lab, because there's many moving environments or the products or skills that related to a moving environment, we'd be able to use our Stair Lab to do the test. So I think we only give you a really high level and quick sort of like introduction of our 4 CEAL labs, as well as the 2 additional labs that also be able to simulate the weather condition or the moving condition. But we definitely would like to invite you to a real tour and also to learn more about our capacities. On top of the CEAL, we also have a couple of other labs we'll be able to simulate different environment. For example, Care Lab is simulating a hospital patient room. And we also have a home lab. Home lab actually will be able to simulate a very typical, probably 1-bedroom unit, which we have bathroom in there, a bedroom, kitchen, living room, and even a staircase, as you can see on the top right corner of this image. So we'll be able to study a lot of products, especially now we're looking at how we better make people rehab at home and aging at home. And we also have a lab we call the Sleep DB, which is a lab, it can be totally isolated from noise, and we'll be able to study a lot of sleep-related disorder. We can evaluate the products there. We can create a different type of noise environment, because we basically can take out all the ambient noise out and then add in whatever the noise you would like to simulate. And at our Linhurst Center, we also have a rehabilitation engineering lab, which have access to a lot of spinal cord injury patient, as well as this lab has capacity of doing many of the study related to the sitting, to the walking, and to mobility, mobility-related studies as well. So I think today's purpose of we give you a quick peek of what we have is really we want to invite you to work with us, because we believe that our labs, especially the very unique CEAL lab, for example, the driver lab, the stair lab, the street lab, the winter lab, they have the capacity actually to testing products and also maybe help some of the our collaborators to evaluate their products and also to explore some of the potential question that you might want to looking into. So this is really an invite for you to contact us and to learn more about our capacity and to explore the possibility of we be able to work together. And if you are in Toronto, you probably already know where we are. But if you're from other part of North America or even the other part of the world, we are in Toronto, and this is the sites. But the CEAL lab is in the center of the city, Toronto. It's called the University Center, which is highlighted in blue here. And we have other sites. And of course, they are mainly have patient rooms and also the day hospital and outpatient centers in those, as well as some of the other labs in those sites as well. So here's our contact information, and there's a QR code. If you scan, will directly take you to our website to showcase the labs that we mentioned today. And for winter lab, for CEAL labs, you actually be able to take a virtual tour. And now we're going to open the questions. Of course, if you wanted to invite your colleague also to explore the capacity we have, please contact me. I have my email here. We can book one-on-one meeting and to further give you more details and maybe potentially booking some like on-site visit, maybe in September or later this year, depends on the pandemic situation. So I noticed that we have a couple of questions. We will have Tilar to monitor today's question. And probably Tilar will first read the question, and then Tilar will direct those questions to the people that be able to answer the questions. We'll have all our panelists turn on their video, so you'll be able to see them, and also they be able to answer your question. Okay, Tilar.
All right, so hi everyone. It looks like we have two questions here. The first is, are you currently doing research in the driver lab on cannabis and opioids? If yes, have any of the results been published? So I think this is a question for Jenny.
Yeah, and Bruce can weigh in on this as well. So we are currently doing research on both of those topics. Unfortunately, we're not able to progress with the research studies when we had to limit the on-site research due to the pandemic. But what that means actually is that it's a good opportunity for people who are interested in being involved with that research or have specific questions that they would like targeted as a part of that research to get in touch with us. Because we're still at the point in time where we can direct and target our questions strategically, depending on sort of a needs assessment. So the answer is, as far as I know, and Bruce can again step in, the primary investigator on the work with the opioids, and in a large part the cannabis study as well, is Dr. Andrea Furlan, F-U-R-L-A-N. And she she's an expert physiatrist who specializes in pain. And she does, I think, have some conference publications that have come out in terms of the opioids in driving, but nothing that is currently forthcoming with the cannabis work.
Yeah, that's correct. That's what I was going to say. So there's been some conference papers published on the opioids work.
Okay. All right, the next question is, for the driver lab, can you incorporate a client's control algorithm for driving controls? Does that need to be in a specific environment?
That's definitely a question for me. I don't know exactly what you mean by driving controls. I'm assuming that you mean in the context of automated vehicle for the actual control of steering wheel, throttle, and brakes. In which case, the short answer is yes, we could incorporate anybody's control algorithm into the driving controls. The entire simulation is an open framework, so we can take control of whatever aspect that we want. Does it need to be in a specific environment? Not really. Our primary control framework runs in MATLAB Simulink. But we can work in just about anything, especially any sort of C binding code works as well. But we can hook in just about anything we wanted to.
Okay, that's perfect.
If that's not exactly what you meant, then feel free to ask more questions and I can answer that later.
All right, next question is, are you able to load 3D models of buildings that are being designed in order to identify design or wayfinding issues?
So that would probably be best considered as a street lab question, and the answer is yes. It's often those buildings would be done in terms of an architectural drawing, which doesn't work all that well in the gaming world. We basically have to render them like a game would. So if it can be stripped down to something that renders in a gaming type environment, then we can run that in Street Lab. We also occasionally do use VR goggles as well to look at those sorts of things if need be.
Okay. Are there any research opportunities for first-year health studies undergrad students?
I mean, I think Andrew could maybe, as the sort of the primary person responsible for our restart activities, might provide some insight into the when of this. So typically we are very keen on having students come and work in the lab through internships, volunteer opportunities, or outside projects. So, you know, if you are interested in those things, you can contact us and see what those opportunities are. I don't know if, Andrew, you have an update as to the current status of things, because we did have to put a hold on onboarding new students given the current circumstances, but I'm not sure. Andrew,
there is still a hold. It's under regular review. So at the moment, I would assume it's on hold. That doesn't mean that someone couldn't contact us so that we could look into it. But yeah, and as the numbers in the city are very high at the moment, that makes it a little more complicated in the short term. But certainly you could contact us.
Okay, next question is, what is the home lab addressing and how would it study the psychological and physiological aspects?
I think I can start, and maybe Andrew, you can also add on home lab's capacity. I assume that when you say what is the home lab addressing means what type of research questions we're addressing. Basically, the home lab is simulated a home environment. We be able to test out, for example, some of the fall detection device for seniors who is home alone, and those devices we be able to use that to test. And we also be able to test some of the the device that actually targeting Alzheimer patients, for example, to remind them how to do the hand wash task and also go to kitchen to boil water. And we have some of the research in that. And if you have products or devices that you would like to test in a home environment, home lab might be able to address those tasks as well. And how we study the psychological and the physiological aspects, probably Jenny can answer the psychological part. And for physiological part, we be able to monitor your heart rate, your blood pressure, and your movement. So all those physiological measurements, I think, for example, the ECG, the EMG, the EKG, we all have ambulatory monitoring system that we'll be able to bring up to our home lab, and we'll be able to get those data. But for the psychological aspects, maybe Jenny, you can address that.
Yeah, I mean, it really depends on the project essentially. And so as Sophia mentioned, we have the capability of measuring sort of physiological responses, but also behavioral responses. So we can use like the motion tracking systems and other methods of measurement. In terms of the psychological, we use all kinds of different batteries. So a lot of what we do involves a general assessment session with our participants, which would include a battery of cognitive and sensory, motor types of batteries of questions using gold standard measures, for instance, to characterize our participants. And so it really is customized, I would say, to the question of interest.
Okay, thank you. Next question is, does KITE have partnerships or cooperations with other institutes, examples in Europe or Asia? Maybe Sophia or Milos can weigh in here.
Yeah, I can start, and Milos probably can add as well. So yes, we have many, especially academic partnerships in Europe and Asia, and we also currently looking for industry partners in Europe and Asia. And the one thing about partnerships in Europe and Asia is because the time difference, we always sort of like entertain the idea of for Asian partners, we can run a nighttime shift. And for European, of course, we can accommodate European time as well. So in short answer is we're really looking forward to the partnerships from all over the world. And if there's our partners or institutes, companies want to learn more about our labs and how to collaborate, please contact me, and we can definitely looking into those possibilities. Milos, would you like to add?
I'll just add one thing. What is important is scientists individually have various partnerships with different countries and different scientists worldwide, and we nurture that and we encourage that. What we are right now working on, and Sophia is an integral part of that process, is trying to create partnership with institutions. And we've been working with a number of institutions to create those partnerships, which is kind of agreements, institutional agreements in how we'll conduct research and have exchange of people or run joint seminars or apply for granting or funding. So we are doing that right now, and I think that's been showing to have some very exciting opportunities and possibilities. But not only with academic institutions, we're doing this also with industrial partners, and we've been in the last 12 months, despite COVID, we have signed a number of really strategically important agreements for us in R&D space.
That's perfect. All right, the next question is, what max lateral/longitudinal acceleration can the moving platform support?
Our primary motion platform is a Rexroth built hydraulic hexapod using 60-inch stroke actuators, so we can move a little under a meter in each direction at a maximum acceleration of 8 meters per second squared, so just under 1 G. But of course, you can only sustain that for a relatively short period of time because of the displacement travel. So we use motion cueing algorithms to be able to simulate larger or more sustained accelerations within our workspace.
Okay, next question is for Driver Lab. Do you have a built-in system / platform for HMI and infotainment development and testing?
Not exactly, because the point of Driver Lab was never to do the actual design of vehicles. We want to be testing the people in it. So we tend to put different people in it as opposed to different hardware systems. However, as I said, it is an open framework, so we can tack on kind of whatever we want. We have on numerous occasions put in things like an Android tablet with some sort of display on it that's custom built in order to run it. But the actual car is, as Jenny mentioned earlier on, it's an Audi A3. It has the original interior in there, so that interior is no more modifiable than a regular car.
Thanks, Bruce. Oh yes, Milos.
I just want to add something to what Bruce is saying. Absolutely correct. But what is relevant is because of the interfaces and because of the reactions of people in different situations, that type of studies can help people who are designing cars or future models to understand better physiology and sensory motor interactions, so that these interfaces, displays, and whatever it's relevant in the design of the vehicle can be adjusted, that it has a better performance and better interface with the user.
Perfect. Next question is, do studies tend to be proprietary to specific industry partners from start to finish that restrict any protocol add-ons? In other words, if somebody wants to do a simple add-on component or variable to an existing study for quick anecdotal learning, is that possible? Example, add an insole to boot for proprioception comparison in a fall study.
So maybe this is a question for me. We have a responsibility to our partners to protect their intellectual property. So if one wants to have their technology tested in combination with the existing product or the product that we're testing, we will have to have arrangements and meetings with those parties involved. And if the party that already has experiments running with us is interested in partnering with a third party to provide additional data points or information or testing of potential products that can be integrated into, I don't know, shoe sole, we are very interested in that, and we will facilitate that, but we cannot force or nudge the partner to accept that. They have to be willing to do that.
All right, and
but of course, not all studies are with a partner at all. Often they can just be PI driven. If anything was PI driven, then it makes it even easier to add a tack on.
Thanks, Bruce. That's a very important point.
Totally makes sense. Okay, and the last question is, was home lab built in accordance with infection prevention and control procedures?
Yeah, so the home lab, maybe I can answer that question. Home lab was originally built with intent to replicate middle-class home in Toronto and how the middle-class homes actually look in downtown Toronto. So that was the main consideration, because we wanted to test different techniques, technologies, processes, and assistive devices in such environments, how they perform in everyday environment in the house as they exist right now. So that was the main motivation of design. The infection control was not considered at that time, as infection control was not considered until 2 years ago when we were building homes in Toronto. So.
I mean, in terms of infection control, it would have to meet the criteria that is dictated by our UHN infection prevention and control that applies across the whole hospital and organization. And there are studies that are being done in Care Lab that are led by Dr. Jeff Fernie that are primarily interested in infection control, if that's something that you're also interested in, including developing hand hygiene prompting systems that can be implemented within the hospital setting and also beyond, including hospitality settings and things like that. So if infection prevention and control is something that you're interested in, there's also active research in that area.
Thanks, Jenny.
All right, I think that's it for the questions. Milos, I believe you will be closing.
Sure. I mean, this was just the purpose of this was just an introduction to give you a sense of some of the capabilities. I'm absolutely certain that we have not covered all possible options. And if you can see, as you've seen in this question and answers period, I would answer the question in one way, and then Jennifer will come and correct me that I don't know what I'm talking about because of these other things that are going on. So what I'm trying to suggest is, if you have a particular interest and you would like to do to look into running an experiment or particular protocol with us, we can create a team around that idea and a protocol, work with you to find what is the most appropriate setting in our laboratories for you to run these experiments, and we'll assemble a team of scientists who have the expertise in the space and potentially support that project should you decide to go that way. And one of the very important things, I don't know if that came across, we have a very diverse team. We have 50-something scientists, which, like Jenny, go for psychology. Some of them are engineers, others are neuroscientists, physiotherapists, occupational therapists, and speech and language pathologists. So we have very broad, and artificial intelligence, we have very broad base of knowledge that, and we can actually engage these people to help you solve your problems if you're interested in working with us and partnering. And we are motivated to do that because by doing that, we solve the problems for our patients. And by doing that, they don't have to come to a hospital, or they get out of hospital faster, or when they get out of the hospital, they can live independent and fulfilling lives. And that's the motivation of Kite and what we're trying to accomplish. Jennifer, you have anything else you want to add to that one?
No, that was excellent. And I will just reiterate that that we are really excited and very happy to collaborate with all kinds of different people, because we really feel that the more diversity that we have, you know, in as a part of our teams and our collaborators really informs the best way to have impact. So please reach out to us if you've seen anything that you think would be create good synergies with the types of things you're trying to achieve as well.
And if you may not have an answer to your need, we will try to connect you to people who do, so have potential capabilities that we don't have. So we'll try to work with you to find out what are the people and what kind of team you may need to help you answer your questions.
Yeah, and if you think your colleagues or other people, you think they might be interested in knowing our facility and would like to work with us, feel free to forward the information and also forward our contact information.
And I do believe the slides and the recording are going to be made available after as well and shared with the attendees. So that's another mechanism.
And it's going to be available on our website as well. All right, I think that's conclude today's webinar, and thank you for spending 1 hour with us, and looking forward to hear from you, and have a good afternoon or evening, depends on where you are. Bye for now.